Hi everyone, good morning or afternoon depending on where in the world you're watching this from, and thank you so much for attending this presentation. My name is Walter Nonamaker, and it's my pleasure to speak to you today on behalf of Healing Waters International. I also have the honor of co-presenting with my colleague Hannah Loki here, who will be taking the microphone in a bit. We'll introduce ourselves a little further and talk more about Healing Waters in a few minutes, but since this is a storytelling style presentation, I'd like to start in the middle, zoomed in to the thick of the story. Then we can zoom out for context and the bigger picture. So a story within a story, and some technical lecturing within a grand global undertaking. So let's start on a beach, on the south coast of the Caribbean island of Haiti. We climb out of the outboard dinghy that took us here and we wade through the surf up onto the shore. That's because the community of Onsite in the municipality of Belle-Anse, Sud-Est Department, Haiti, is only accessible by boat. And it's sweltering hot here. The sand is just baking, heat waves radiating up off it and distorting the cluster of 90 or so huts just beyond the beach. And the beach is lined with dilapidated wooden boats and covered with piles of fishing nets. And then there's rows upon rows of fish that are drying on tarps and racks. The whole economy of Onsite consists solely of selling fish they catch to merchants that come by boat to collect them and pay cash. That's the only source of income. And the people here also rely heavily on their fishing for subsistence. But outside of that, all basic staples need to be purchased, imported via boat. And that included water for drinking. Since the community had no access to drinkable water, all drinking water had to be purchased in jerry cans brought in by boat. And this was a very highly inefficient financial burden that was estimated to tie up as much as 1/3 of gross household income. Can you imagine having to spend 1/3 of your gross income on the water that you need to drink? And of course, that in turn would limit resources available for nutrition, healthcare, education. Then the leader showed us the community's sole non-seawater source, and it was a shallow hand-dug well among those clustered shacks and latrines up on the sandy earth up from the shore. And there was just a little pool of sort of grayish, oily-looking water at the bottom with some garbage floating in it. And this water was brackish. So total dissolved solids, or TDS, is the main parameter we use to describe how much ion or mineral content water has. In other words, how salty it is. Most bottled water's TDS is between 20 and 50 milligrams per liter, and the World Health Organization's limit for drinking water is 500 milligrams per liter. To give you some context, seawater is around 35,000. And we measured the well at Onsite at 10,000 milligrams per liter. So very brackish, about 1/3 as salty as seawater. Then during our assessment, we learned a very disturbing fact. In order to stretch resources and have enough water to get by, spending as little as possible, people were actually supplementing, actually mixing and diluting this well water into their purchased water at just the amount of brackishness they could tolerate. And we could actually see the health impacts of this practice in the community. Several people were visibly sick and ill, and even beyond that, a lot of the older people just looked haggard, just expended, worn out. One woman talked to us about her back aching and pointed to where her kidneys are. Okay, let's stop here and zoom out to see the bigger picture. We're gathered at this conference discussing building resilience faster, and as Healing Waters, we're focused on resilient societies through innovation and technology. Now, a big consideration in the call to bring clean water to all is that many, especially low-resource rural communities, not only lack reliable water access, but in fact the nearest available water sources that could potentially be used to create that access contain physiochemical contaminants that would be harmful to human health. The quintessential case of this would be coastal communities worldwide where the water table is brackish, right, high in TDS. But similarly common situations would be where groundwater regionally contains either arsenic or excessive fluoride, trace heavy metals from industrial discharge, etc. This will become even more prevalent and problematic over time. Due to population growth, climate change, and industrialization, many communities, a growing number of communities, are left with water supplies that are brackish or contain these exotic contaminants. And as we've witnessed very viscerally at Onsite, these communities globally suffer from degenerative conditions, cancers, kidney failure, etc., due to mineral and metals contamination on top of the gastrointestinal illness of lacking safe drinking water. Now, as fresh water becomes scarcer, people turn to whatever source they can, which could mean exotic contaminants or brackish water. So for a society to be resilient, it needs to be able to face this challenge. Another thing is that these constituent profiles are not static, they're changing over time with aquifer depletion, shifting populations, trends with industrialization, use of pesticides, as eventually sea level rise. So it becomes vital to have treatment solutions that can sustainably address the whole spectrum. But how to address it? How to navigate this fine line between robust technology for adequate remediation and financial and operational sustainability? How to make this affordable and make it work long term? I've asked myself this throughout my career, and certainly wondered it as I was standing by that brackish little well on that sweltering beach in Onsite, feeling a bit powerless, honestly. How are we ever going to make something work here, make it work long term? So my background is in water treatment engineering, and I can attest that I certainly have felt daunted by the uphill challenge at hand here. I definitely felt that on my first day at Onsite. This really is a conundrum. And my sense is that the idea of advanced treatment for challenging water profiles in the rural context has acquired a certain taboo within the WUSH sector. We don't want to touch it. We tend to assume advanced treatment is simply not feasible in rural or low-resource contexts because we've often adopted such rigid definitions of self-sustainability and how to turn something that's robust and expensive into a revolving door in a low-resource context. Surely something has to give, right? So we end up prioritizing interventions in contexts where groundwater can be made potable with simple filtration. And as a result, the most vulnerable communities with the greatest need for improved water are often overlooked, even by the nonprofit sector. So let's come back to Haiti, but back up for some context. By the time we were doing an assessment at Onsite in 2018, Healing Waters had already been working in Haiti for 7 years and had been through quite a bit of trial and error. So what had we been trying to achieve in Haiti? The model was to establish and empower locally owned, sustainable water kiosks that provide purified water to their communities in exchange for an affordable monetary contribution, often a family monthly quota, which was calculated to collectively cover the operational costs and accumulate savings for future capital replacements. So, a small water enterprise. And this is still a fundamental aspect of our approach, and to date, Healing Waters has established 488 of these small water enterprises in communities across 17 countries. But in Haiti, sustainably bringing reliably safe water to people and ensuring a genuine impact brought unique challenges inherent to the context. You see, up through 2010, most of the treatment solutions Healing Waters deployed were built around ultrafiltration, sulfonated polystyrene membranes that reliably remove pathogens and are very resilient and energy efficient. And we were using these mostly to address microbiological contamination in surface water people were drinking all over the world, but UF doesn't address minerals, metals, or salts. And one thing we quickly identified in Haiti was that most of the need and opportunity for impact was in coastal communities where the groundwater was brackish. Therefore, our ultrafiltration-based equipment wouldn't be an appropriate fit. Developing safe water solutions for places like Onsite actually dovetailed very nicely with a broader trend in the evolution of Healing Waters' mission. What I'm referring to is we started seeing a significant and undermet need for a niche implementer to serve partners within the sector and contribute to broader interventions by bringing a focus on sustainable treatment solutions for challenging water profiles, even in low-resource contexts. We started understanding the global trends and forms of water access marginalization that I introduced a few minutes ago, and we started seeing the uneven distribution of nonprofit and grant-funded water interventions going to regions where groundwater is low enough in TDS and free of glaring physiochemical contaminants that borehole water can be made potable with basic filtration and disinfection, and how this leaves regions where water quality poses the greatest threat to health underserved. As an aside, exotic contaminants often are present but untested for in groundwaters where the wash sector does implement boreholes with only chlorination. And that sheds light on the need for more scrutinous testing to ensure compliance with SDG standards and what we call safe drinking water. So, seeing this, we started actively looking for opportunities to partner and bring sustainable treatment and remediation solutions to regions where this presents both a challenge and a desperate need. Since then, we've encountered regions and populations whose available groundwater sources contain toxic levels of arsenic, fluoride, heavy metals. For example, in southern Guatemala, we've encountered and designed remediation for lead 64 times the WHO standard, with mercury also present. And people were drinking that. So, zooming back in a little to Onsite and the 34 communities like it where we've worked to establish community water enterprises in coastal Haiti. The fundamental approach is to design each intervention, infrastructure, treatment equipment, to both the size of the population, but then also to a full lab test of samples of the raw water sources, such as groundwater, available in the vicinity. So as many of you may be familiar with, the most feasible and cost-efficient technology available for removing TDS or salinity from water is reverse osmosis. But as you also know, reverse osmosis is complex and highly energy intensive. It requires high pressure. And these communities where we're trying to make reverse osmosis work have no electricity at all. Furthermore, in the context of rural Haiti, literacy and even relevant vocational training are very limited. So how can you expect a system like reverse osmosis that's so robust and complex and energy intensive and requires monitoring and measuring and adjusting and troubleshooting and acquisition of consumables and routine maintenance procedures? How can you expect all that to work in a context where there is no electricity, where logistics are challenging, and where people lack the basic literacy to operate a fine-tuned enterprise? So, in order to make this work, we had to contextualize the available treatment technologies, but also focus on training and capacity building. In order to provide fresh drinking water at a place like Onsite and other rural communities, we do rely on reverse osmosis as the core technology for TDS removal. But let's look at 3 of the ways that we've adapted the technology to make systems work long-term in this challenging context. First, we've designed a system where the pumps required to drive the water at high pressures can be powered directly by solar panels, using what we call flex, or variable voltage pumps, that can operate on DC, on direct current. And while this does constrain systems to operating only during sunny daylight hours, it eliminates the burden of the batteries and inverters that are typical to solar energy systems for pumps. And that, in turn, drastically decreases future replacement costs and improves the sustainability of the system. And then we address that operating time frame constraint by ensuring a cushion of treated water storage with gravity feed. Secondly, we've learned that it is of critical importance to build out water systems by mounting components on a wall or situating them across the floor, each in their place to form an intuitive treatment train, as opposed to having the system sort of condensed or compressed into a skid mount or a packaged assembly or a box, because then it can become a black box. It's absolutely key that operators are able to see and access each component in order to understand, monitor, and ultimately maintain them. This way, operators can actually pinpoint the failure and determine needs for replacement parts and change things out such that the system itself never reaches the end of its useful life altogether. In contrast, we've seen that if a system is too self-contained, local operators can write the whole thing off as broken when just one internal failure occurs that should be easy to fix if it were intuitively accessible. And that was actually another lesson we learned as we first started to develop a contextualized model in the face of brackish water sources in Haiti. So the first solar-powered RO systems we designed were self-contained, and we liked to think of them as plug and play. And we could QC test them before deployment. And that's all great, and they were beautiful. But we soon realized that operators need to see and engage with a treatment train laid out across a room to really own the technology. So direct DC solar power and in situ build out using heavy plumbing and durable accessories. Finally, the third adaptation is that Healing Water's reverse osmosis builds are, to our knowledge, unique to the sector so far in how they employ custom-built hydraulic controls to optimize between feed pressure, TDS removal, recovery rate, and blending. Now, these controls would be typical, they would be standard in a municipal scale RO plant. They're standard technology. But their novel use in this context, in a community context, permits feasible operations even at such a rural scale. And this is really critical in situations where power and therefore pressure are limited, and also where the water source is scarce. For example, if the discharge of the well being used is a limiting factor in production capacity to serve the whole community, control boxes allow us to push the envelope. They let an operator tweak and optimize under all the constraints to get a viable result. And these designs typically use series recirculation to get recovery rates as high as 74% while producing effluent TDS at around an ideal 50 milligrams per liter. Okay, but all that said, contextualizing the technology is only half the battle, maybe less than half. The other factor is something we've learned over the years through trial and error. We've learned that culturally contextualized and extensive management training is absolutely critical for community projects to remain active long term. This is where I'd like to introduce my colleague Hannah Loki, who serves as our senior program manager, to discuss training and empowerment as well as measurable results. So Hannah?
So our team in Haiti approaches each intervention by first working to ensure commitment at the local leadership level, and then thoroughly training designated community members in hygienic operation as well as routine maintenance and troubleshooting of the water system. Actually, they engage these future operators in installing the equipment initially over the course of 3 days to deepen their awareness of the process and components. Then, our staff continues to offer regular support through in-person visits to reinforce training, resolve any advanced issues, or assist in sourcing replacements. Because these visits are at no cost to the community, there is incentive to report any concerns rather than ignore red flags. These visits start at a minimum of quarterly and then taper down over 5 years as the local leadership gets more experience under their belt. One unusual thing about Onsite is that all of these training visits, and even bringing construction materials and equipment for installation for that matter, had to be done by boat. Our Haiti team has made a lot of boat rides from the nearest marina in Valence. So the big question is, does this approach really work? Can these interventions survive and sustain themselves long term? Well, nothing is perfect, and we're still learning, but the performance of these interventions in coastal Haiti that we're mentioning would indicate the answer is yes. 100% of these water projects implemented since adopting the approach are still operating. Across 15 projects Healing Waters has implemented in Haiti requiring RO treatment for brackish water, our staff have collected 86 quarterly monitoring reports showing key performance indicators. Of these quarterly reports, 78% show projects are setting aside their planned savings quantity for future replacements. The average uptime of projects is 93% of the quarter. These projects are serving communities as small as 500 people and as large as 3,000 people. All product water from Healing Water Systems meets WHO standards and Haiti national water quality standards. So the data illustrates that powerful treatment systems can be managed sustainably by low-resource communities. Now I'm sure you're wondering about the results from Onsite specifically. The kiosk at Onsite sells about 1,000 jugs of water a month, serving 374 people. That volume is more than enough needed to cover the operational costs and save for future maintenance. Over the 9 quarters we've collected monitoring data for, only 1 quarter did the project not put aside the full savings as planned. In fall 2020, Hurricane Laura hit the site, causing some water damage to a pump. Nevertheless, the operator contacted Healing Waters technicians and were able to assist in repairing the pump, and the project has been up and running again. Amazingly, because the water system has run so cost efficiently and been so light on maintenance and repair burdens, the community has been able to reinvest a surplus of the project revenue from those affordable monthly contributions and actually built a simple sanitary block that constitutes improved sanitation for the very first time in this community. What a poignant example of how empowerment and a sustainable enterprise can snowball. Recently, our Haiti country director, Wesley Hippolyte, mentioned to us an anecdote that made his day. Normally, whenever our field staff get a phone call from site partners, it's because there's a troubleshooting issue, which is fine. We're there to help, and we're glad that they're reaching out. So when he saw a call coming in from Onsite, he thought another boat trip was forthcoming. But actually, the leader was just calling to say hi and tell Wesley that everyone was content and impressed by how smoothly the water equipment was working. There was no troubleshooting request at all. That really says a lot, especially coming from a culture where phone airtime is such a valued commodity. But this smooth, financially self-sustainable operation at Onsite would not be possible if Healing Waters charged the community even break-even compensation for ongoing technical support. Remember when Walter said that something has to give when pushing the envelope in navigating such a fine balance between robustness and cost efficiency? A financial burden for ongoing support would push the marginalized community like this into the red. So our finding is that subsidies and ongoing tech support may be appropriate and equitable as part of bringing clean water to all. In our experience, this support at no cost to the community has been key in maintaining viable safe water service and avoids the starts and stops that can be the downfall of safe water interventions. We don't believe this contradicts the principle of self-sustainability. We think the sector needs to reassess what it means for a project to be self-sustainable to ensure undue burden isn't being placed on the most marginalized populations.
Okay, let's summarize the conclusions and takeaways we want to leave you with. Salinity and exotic contaminants in water supplies of marginalized populations are on the rise. Certifying water quality, in addition to supplying access, becomes more vital than ever to ensure health and safety for all communities. Prevalent exotic contaminants, often not tested for, should not be overlooked in the rush to consider populations served with improved water access. It is challenging, but possible, to bring robust treatment for salinity and chemicals or metal contamination to marginalized and remote populations in a way that is affordable and sustainable. Communities like Onsite can be empowered to manage complex water treatment systems even where literacy and tech experience are limited, as long as training and ongoing support are properly managed. Thank you so much for listening. If you'd like to learn more, or if you've identified needs for water treatment support, we'd love to connect with you.